Although limits is the culmination of just about everything we've covered throughout this course, there are a couple of topics that I want to take a moment right now to go back and review before we get into the meat of our unit on limits. So let's get ready for limits. The two topics that I want to go back to are lesson 0.2, which was one of the first lessons of the year. All the way back in August, we need to go back and practice factoring. And then to build on top of that, we're going to go back to lesson 2.4, simplifying and analyzing rational functions. One of the good things about this particular unit on limits is it's going to afford us an opportunity right before the end of the year and our final exam to go back and review a lot of the basic skills that we've been developing throughout the year and finally are going to put it together into a nice, delicious sandwich in this particular unit. So let's start with factoring. Take a moment. Here are 4 problems. I'm going to give you no other instruction. Just take these 4 problems, pause the video right here, factor these 4 problems, and then hit play. You hopefully should have no problem factoring these 4 expressions. Here are the 4 answers. Take a moment, look at your answers, look at my answers. My answers are correct. If you got any of these wrong, then I want you to go ahead and continue watching this video and look to see if you can identify what your mistakes are. But if you got them right, you're done. You can go ahead and stop the video now and go ahead and complete the practice. Enjoy. So if you're still listening, that means you made a mistake. Let's look at each of these 4 problems in turn. So 2x squared minus x minus 10. I have a quadratic trinomial with 2 variables in it, so we're going to be factoring using the AC method. Now, of course, what we should always do is factor using the GCF method first. Look to see is there anything in common between A, B, and C. In this case, there is nothing in common, so I don't have to worry about it. So we'll just go straight to A times C, which will end up being negative 20. Factors of negative 20 that add to the B value of negative 1. Think about it for a quick second. Hopefully you should get negative 5 and positive 4. Breaking into my double bubble, I'm going to take the A term, 2x squared, drop the square, keep the 2x, and put that in both bubbles. I don't write 2x squared, I write 2x in both bubbles. Then the negative 5 and the 4 get sprinkled in to the other side of each bubble. So I now have 2x minus 5 and 2x plus 4. I'm not done with this method until I simplify. I look at each respective bubble, 2 and 5 within the 2x minus 5, and ask yourself, just like a fraction, can that be reduced? 2 and 5 cannot be reduced, but 2 and 4 absolutely can be reduced. I can divide both of those by 2, so that's what I'll do. And I get x plus 2 on the second bubble, 2x minus 5 on the first bubble, and that would be my final answer. Remember that when you're factoring, you can always double check to make sure that it's correct by re-multiplying it through. 2x times x is 2x squared. Negative 5 times 2 is negative 10. And if you do the outside, 2x times 2, and then the inside, negative 5 times x, that's going to give me 4x minus 5x, which gives me the middle term of negative x. So I can check it by multiplying every single time. On the second one, I'll use the AC method, but here's where I want to be super careful. Anytime I have a leading negative, factor out that leading negative. Anytime I have a leading negative, factor out that leading negative. I have a leading negative, so we're going to start by factoring out the leading negative. Treat that as the GCF step. So if I pull out a negative, that leaves me with a positive x squared minus 5x plus 6. Continuing on with the AC method, A is now 1, C is now positive 6. So A times C would be 6, and I'm looking for factors of 6 that add to negative 5. Those factors would be negative 3 and negative 2. Going to the double bubble, the A term is x squared, drop the square, put the x on both, and then negative 3 and negative 2 go in the other part. X minus 3, x minus 2 is not my final answer. The fully factored answer would also have to include the negative that's out front. So that would be my final answer. Now, just for fun, let's consider if I had done that without factoring out the negative. I would have started A is negative 1, C is negative 6. I would have still started with A times C being positive 6, but now I'm looking for factors that equal a positive 5. I would have gotten positive 3 and positive 2. I would have gone to my double bubble. Negative x squared, drop the square. I should have put negative x on both bubbles and then plus 3 plus 2 on the other part. And then from here is where I get a little stuck or a little confused. Clearly this is not the answer because negative x times negative x does not give me negative x squared. 3 times 2 does not give me negative 6. And then if I try the technique I had over here, is there anything I can divide out? Well, on both of these, I could actually divide out a negative 1, leaving me with x minus 3, x minus 2, which is still not the correct answer. X times x does not give me negative x squared. Negative 3 times negative 2 does not give me negative 6. By not factoring out that negative at the beginning, I've ended up with something that's irredeemable. There's no way to get to the right answer if I don't factor out that negative at the very beginning. All right, here are 2 more. You've already tried them, so let's look at them together. 30, 25, and 30. Now, of course, I could jump straight into the AC method, but boy golly, do I not want to do that. Those numbers are going to be huge. I notice that all of these numbers are divisible by 5. So I'm going to start by pulling out a 5, and I leave behind 6x squared plus 5x minus 6. Now I'll do the AC method based on 6 and negative 6, which is going to be negative 36 factors that add up to the B term 5. Factors of negative 36 that add to 5 would be negative 4 and positive 9. Breaking it up, I'm going to take the 6x squared, break it into 6x and 6x, negative 4 and positive 9, and then each of these can be reduced by separate numbers. The first pair could be divided by 2, the second pair by 3. So that leaves me with 3x minus 2 and 2x plus 3, but remember the GCF is part of my solution, so 5 parentheses 3x minus 2 parentheses 2x plus 3. And the final one hopefully required no work whatsoever because you immediately recognize that as a difference of squares. 4x squared is 2x times 2x, and 9 is 3 times 3. And as long as it's a difference of squares, we can just break it up into 2x plus 3 and 2x minus 3. It does not matter what order we're in. Anytime you have a difference of squares, a squared minus b squared, it will always factor into a plus b, a minus b. Remember, if you are having any trouble with factoring, go back on Canvas and find lesson 0.2 and start at the beginning and work your way all the way through.